Thank you, Ayesha. Thanks everybody for coming. I think the challenge here for me was uh, trying to make this interesting for your range of backgrounds and interests, but also try and contextualize the work that I'm doing so that you can tailor your questions. So I'm interested in the Q&A bit that comes with this, because that might be where we extract a bit more information from one another. Drones and geomatics, basically, the typical application of drones that you see quite often is photo and video, but increasingly in professional environments, they're being utilized for precise data gathering and development into different models, different data sets. So what I do is I'm fairly central in a team here based locally in Nottingham, Bridgeway Aerial, and we're on the framework for Network Rail. This image that you can see, it's actually very rarely the case that we get to take nice photos. We're really out there doing detailed inspection work and mapping. So I'll give you a bit of an overview of what we do on the railway and how it is that we get onto railway, because railway, for those of you that worked in the railway or worked in railway infrastructure, it's a different world and comes with its own language and its own rules, and it's a fascinating place. I'm the senior UAV pilot data analyst at Bridgeway Limited. I took on the role a couple of years ago, and I've been developing a team there. I've since trained up 2 pilots and 2 data processors. We've now also got an operations manager that helps running the day-to-day work, and another administrative assistant. There's about 6 of us in the core team that focus entirely on drone work. I did my part 1, my part 2. I did my part 1 in Lincoln. I went to Australia, worked out there, and my part 2 was at Trent. So graduating from Trent, I was very fortunate in obtaining a position as a research assistant at NCU, and that's where we first started working with drones. That was 2013, so a good 7 years ago. You couldn't buy a drone there unless you were the US military. A lot of brands that we know now didn't exist. We had something made by a few guys in London. It was a one-off device, and we got some really good use out of that. Since then, I've been a proponent of drones, and what I've been interested in is the workflow. As I said, it's all well and good flying this object around, but if you can't directly apply the potential from these devices to your workflow, your pre-existing workflows, then you may struggle to see the value of them. So the workflow I've developed is probably no longer something you could call unique. I haven't written any software. I haven't manufactured any kit. It's simply I guess a system that was put in place to be built into an architectural workflow that was born obviously out of the work I was doing in Oman in 2013. But that workflow, transpires, can be implemented into the railway. My remit is to lead a flight crew and data processing team for the safe acquisition of high quality data sets. And the safe acquisition is really important, and the railway is, for a lot of good reasons, really over the top on their safety critical. The locations we go to are pretty complex and challenging. If I go back, that's up in Berwick upon Tweed. High levels of winds, really busy route for trains, and the winds are just horrendous, and the train station was up quite high. This is at the opposite end of the country, down in Devon, and was a complex job where planning had kept me awake at night, and the time on site capturing data was probably less than 15 minutes. I was trying to capture data of a retaining wall, and could only operate at peak low tide for a number of occasions in the year. And when that peak low tide did come, the time that was predicted that the tide would be out was half what, in reality, was half of what was predicted. So the environments are challenging, and you of course have up to 120 mile an hour trains flying past you. Sometimes we work under what are called line blocks or possessions. Sometimes we don't. Part of the added value of a drone is that you can eliminate possessions and line blocks. For those of you that don't know what those are, they are prerequisites for getting somebody on track safely to do work, and it involves potentially, well, as it suggests, taking possession of a line, and you have to contact the signaller, providing you're suitably competent and qualified. You contact the signaller and you take possession of a line. Obtaining possession in theory requires submitting paperwork 8 to 12 weeks ahead of schedule, and then it's on the day that you may or may not get the line block granted to you. There's a lot of work that goes on in the railway where it just doesn't happen because the workers, despite planning the work 3, 4, or 5 months out, on the day the lines were not handed over by the signaller for any number of reasons. So payloads that we use, LiDAR, photogrammetry, well, cameras basically, and a LiDAR unit. From that we can extract a range of deliverables. A quick snip I took of some of the data of where I've flown the drone. If you zoom into these, they spread out a bit more, but you get the idea. The first image that I took, you saw at the beginning, was up here. The second image, I think, was down here. These are all my jobs, and plenty of places in between. We're one of 4 framework agreement providers for Network Rail. There's only 4 companies nationally that are on the framework, and that's up for renewal every 5 years. Various groups we've delivered for on the network include Historic England, Jacobs, EME, ACOM, Murphy's, Network Rail High Speed, which is different to Network Rail, and they're very proud of the fact. And High Speed, we're currently working on a project in London from Euston Station out to Ruislip. It's about 26 miles of track, and there's about 137 structures that they want examining and monitoring prior to, during, and after the construction of the route that they're putting in. General day-to-day stuff that I've got to do, desktop studies, of course. We do site walkouts as a mandatory minimum on every job that we take on. So once we've obtained the purchase order and won a bit of work, we then begin our we do a desktop study at that point. But then after, if we're awarded the work, we go and do a site walkout and we check it out. We could have a 1 or 2 or 3 person team depending upon the complexity of the site. I might bring in somebody with more railway expertise. Some of the tracks are really complex, and the safety critical element of it can't be stressed high enough. There's some inner London sites which are just horrendous to work around. So that's obviously going to inform your flying. It's going to inform your flying. It's also going to inform the conditions on the day of the person who's operating, the lead pilot, and what they've got to contend with. It's a really important component. The brief may undergo some development or refinement at this stage as new information has come to light. And then, of course, we carry out a risk assessment, and then we produce what's called a RAMS, or risk mitigation strategy. That risk mitigation strategy needs to be approved by Network Rail and the client prior to us arriving on site to carry out the works. We may or may not need some airspace permissions, and we're obviously licensed with the Civil Aviation Authority, and that gives us remit to go and operate safely as per our operations manual. But it still may be the case that we need some additional permissions. If we're operating in and around important institutional facilities like a prison, for example, then we would take the initiative to reach out to them as far advanced as possible. We actually did a flight recently at Wakefield Station. We notified them out of courtesy, and when we called them to tell them we were leaving site, they reported that within the half hour we were on site, they'd received 137 phone calls about drones. So people are pretty hot to it these days for various reasons. The flight planning takes various forms. You do as much as you can from your desk using various applications you've got available to you. Half of those now are on my phone. And we compile all that information and make sure that we try and go through a lot of eventualities. But realistically, until you're on site on the day and you've the drone in the air, there's actually a lot that you can struggle to contemplate and consider ahead of time. I obviously do piloting and then data processing. I'm doing less of that as we grow the team, and then general project management work. Deliverables, some of you may be familiar with these, photo, video, basic stuff, inspection work, really good for planning works further down in advance. So if let's say Murphy's Group want to do some track work and want to replace a big stretch of track, it's a big, complex, dirty job, requires lots of big machines, we can get out there and do a video flyover and just help their planners safely plan the work for their staff. So we're increasingly seeing more of that kind of application. Orthomosaic is a really good deliverable where you essentially stitch together multiple images. They are ortho-rectified, which means they're all essentially flattened out. They have GPS data embedded in them. You can improve the GPS accuracy or the OSGB accuracy by adding traditional control methods from surveys. So if you imagine a topographical survey has got certain control requirements, we would put those in, and you have various kinds of accuracies. You've relative accuracy and you've absolute accuracy. Don't believe most of the claims that people make about the accuracy of their point clouds or their orthomosaics. They tend to be pretty nonsensical. In real way, they have a table, a band of accuracies, and they're pretty stringent. So we very quickly had to up our game to be able to meet those requirements. The hardest one to achieve is sub 5mm accuracy, but with the development of cameras at the moment, that's becoming less resource heavy. Point clouds in various formats for different softwares, 3D meshes, all this can be converted into BIM models, usually through Revit in our case, because that's what I've got experience with up to BIM level 2. And then, of course, when you have the 3D information, you can extract cross sections. Those cross sections can be extracted from the point cloud or the 3D mesh or the BIM model. Digital elevation mapping as well. I'll show you a quick video of a bridge that we inspected. This captures a few things. Let's just hope that this carries across my internet. So we use the phrase boots off ballast, and that's how we want to approach things on rail. We want to stop having to put people on track. It is dangerous, even when you have your safety critical infrastructure in place. Getting a person on track to do anything is dangerous, and there's a lot that can go wrong. And every few months you do hear we are notified of fatality on track within the industry. Really, it comes from a multitude of factors. One small thing is going wrong after the other. You have this sequence, and there's just so many ways that can lead, so many pathways that can lead to an incident. So we try to stay away from track. Now, in this case, we actually put some survey control. We installed it on track ahead of bringing the drone. So to get the accuracy levels the client required, we still needed to get somebody on track. But of course, as you'll see from the data that we gathered, the data that we got was just pretty good. You wouldn't be able to get that using traditional methods. This was a tricky site. Seemed lovely Castleford area. 5 spans, relatively simple masonry structure, but the wind that came through here was horrendous. And I think 2 weeks prior to this, we were supposed to do the work, and all the boats were frozen in. The boats couldn't be moved because it was so cold. The whole canal was frozen. But we got there a couple of weeks later, and the place was lovely, very calm, great conditions for flying, and very little sun, which is perfect for mapping. You don't want any shadows if you can avoid it. So we circumvented the whole structure, went under the arches, flew under the arches with different devices where we could, and maintained a safe distance away from the track. And then we took all that collection of high resolution photographs, took it all and converted it into a photogrammetry model, which is this. This is a point cloud model. You can see a bit of noise here and there, and there's a few gaps, but this is derived from the photographs that were taken by the drone. And you get gaps, particularly when there's vegetation that we couldn't get the drone in or around, or needed to keep a safe distance away. The drone had some issues under the arch. It didn't like the lack of GPS, and also the reflection from the water beneath it were problematic. They're known issues to us and just required some advanced flying to deal with. So that's one project. Another project, very different, very challenging brief. This structure here is known as the Great Wall of Todmorden. It runs close to a railway track, but the base of the structure is a canal, and on top of it is a small forest. Public access along the canal and public access along the top. So this was a complex job to gather the data. And what made it more complex was the shape of the structure. You can see it slightly leans back. There's a couple of curves in two key locations. You've just seen one of them. What the client wanted was a full elevation of this structure. So if you imagine, how could you develop an elevation of a structure like this using traditional methods? You just wouldn't. There's no way the money would be spent to draw up an elevation of this accurately. And how accurate could you make it realistically? So this is just an additional video that I captured, but I spent about a day on site, captured about 1,000 photographs of the whole thing, every brick, every detail, and then we generated that into a point cloud of the whole structure. We also got a load of context in, so we can extract contextual information about the site. But really, again, the client wanted the elevation of this structure. By the way, the resolution is very poor because this is using a free Vimeo account. So to get that up, I had to reduce the resolution of the animation of the point cloud. But you get the idea. So every detail you can imagine is there, and every point has got is georeferenced. So you can select a point and extract a coordinate from it, and then somebody can go to site and inspect that area with the coordinate information that they have. They also have obviously the photographs, which themselves are georeferenced. A few other things we did with this, we generated then an ortho mosaic, which is essentially this ortho-rectified top-down view. They can take measurements from that. This image can have measurements taken from it. It can also be brought into Google Earth. There's a number of different things you can do. You can bring it into ArcGIS and utilize it in there. You can see here that one of the curves and another curve. So it's leaning back and it's slightly curved. It's a horrible structure to try and produce a continuous elevation of. But because we were able to construct this photogrammetry model, we were then able to reorientate the model and produce an elevation. So this video is just a real simple screen recording that I've taken of me just looking at a JPEG. So the JPEG is lower resolution than the TIFF. TIFF is just, the TIFFs are enormous, absolutely enormous. But what I've done here is I've opened up the wall elevation that I've extracted on my desktop, and I've used VLC to just record it. So let's hopefully the image comes up okay. So this is me zooming in on a JPEG. So that, again, the TIFF is a higher resolution, but here we now have an elevation of this structure. Thankfully, the water level has dropped a little bit, so it gave us a bit of grace at the bottom. But you can see that the mortar joints and the vegetation, where there are structural issues that are known that can be verified. Verification of information in structural reports on the railway is really important. So too is being able to add information to reports to say, well, hang on, we've actually found a few things that were missed. It's quite common that reports are done rushed and information gets missed. This allows people to really examine the structure in a high degree of detail and pick out critical defects or superficial defects or any kind of defect they like. And then that gets fed back into a report. So that's probably the only elevation of that structure that exists. Where were we? So rattling on a bit. So deliverables, that gives you a sense of deliverables and what can be extracted from those models. Now the paperwork, just getting to site is a job in its own right. And again, the key word are competencies. There's various people that sit in the hierarchy personnel in the railway infrastructure, and they all have a role to play. And getting things approved is just a necessary evil, I guess. And that includes completion of a series of documents. We produce a site walkout report, risk assessment, mitigation strategy, safe system of work. These are massive in the railway. Safe system works are every single job that somebody does, they have to produce this. Same as a task briefing sheet. Every single job, if somebody wants to go out and kick a piece of ballast, they have to have documentation signed off to do that. We need to get approval, even though we're on the framework. Network Rail Air Ops need to approve our flights. And then obviously we do our own internal documents for flight planning. To be eligible to get yourself signed off on a lot of this work, you have to have the competencies and the training that are railway specific under your belt. As far as I'm aware, you can't get them at university. It's only very specific training organisations that offer this. Fortunately, at Bridgeway, they offer in-house training. So week one for me was getting teed up with all my railway competencies that I needed. Okay, so I've skipped over a few bits, but let's just, we get to arriving at site, to risk assessment and flight planning. They continue up till the completion of the works. So conditions can be different from the day you did your site walkout. Weather can be different. Somebody might have turned up with a big digger on site and it's in the place that you did your launch and recovery from, or you had previously identified you would do your launch and recovery from. There's rules surrounding how close you can get to the railway. How close you can get to the railway under a line block or a possession is different to how close you can get to the railway while it's open. Flying over the heads of other people and flying over the heads of other workers, there's rules for those. And then there's the general aviation rules. I think the interesting thing about this line of work is that we're pulling in 3 or 4 different disciplines. You're pulling in railway, you're pulling in aviation, you're pulling in surveying, geomatics, and all that is being held together through these drone flights. And that we have to navigate all those different areas. So the safety critical stuff involves PPE, full PPE at all times. We got to report anything unsafe that we see at all times. Every time you get on a piece of network rail infrastructure, you're responsible for reporting issues. It could be that there's a fence that has been knocked over or blown over, or there's a tree on the track, or it looks like there'll be a tree close to the track, or there's a lock, it doesn't lock properly and kids could get access, and there's ballast that could fall off a bridge and hit somebody in the head. I saw that last week. So once you're on the infrastructure, you're beholden to a series of good practices and etiquettes and responsibilities. So once we get there to site, check everything's in order, we go through our paperwork again, we make sure everything tees up nicely, and then we begin flying. And once we fly, it's the smallest part of the job, but it's definitely the most stressful. And there's a couple of images there to the right. These are the voltages of the cells and the batteries. It's just one set of data that we have to continuously observe throughout the entirety of the flight, or pay attention to at intervals. Single biggest source of failure on the drone are the batteries. So we have to flick in and out of that information. What you don't want to be turning up to site and discovering that the controller needs a firmware update. That can happen. I've done a lot of work on jobs, gone to bed at night delighted with everything being ready for the morning, get to site at 5:30 a.m. and discover that the manufacturer of the equipment, DJI, have released a firmware update, and that knocks you back a bit. So you can't always mitigate against that. You don't know when they're going to release them, but understanding the firmware for the controller, the drone, the payload that you're carrying, the camera, all that's really important. And it's got to be up to date. Now, there's other information on these screens. So while you're flying the drone, you've got to be monitoring the in-flight data, and you're not just whizzing around aimlessly in the sky. You're obviously going there to come away with a set of data that a client has paid you for, because they require it to carry out works that relate to maintenance, design, safety planning, all these things that we've mentioned. So while you're flying the drone, you've got to be looking at a lot of information. This is obviously not a railway environment. This was a photograph taken during a bit of basic training we were doing. But some of the information here, while you're constantly looking up at the drone, you also got to refer back to all these things. And DJI have since changed this slightly. We use a slightly different system, but this gives an idea of the sort of information. So do we have GPS? If we do have GPS, what kind? Well, what mode are we flying in? Are we flying in GPS mode? It might be that we fly without GPS. If we are flying in GPS, how many satellites are we connected to? In this image, it says 18. There's 18 satellites that are connected to the drone. That'll fluctuate. If you go under a bridge, obviously that drops considerably. I'll not go into how satellites, GPS, and survey work, but basically the higher the better, the lower, the worse off you're going to be. This is a system that tells you when there are aircraft nearby, which is useful. Doesn't always work, so we have it switched on, but we don't rely on it 100%. Communications generally, so you've got two kinds of line of sight. There's the pilot's line of sight to the drone, and then there's what's called the radio line of sight, which is the line of sight between the controller and the drone. You need to maintain both those things at all times, which makes looking at the screen challenging, because you have to also monitor the drone while it's in the air. Jumping across, we've got battery information. Down here, we've got height information. So this one is taken 21 meters above launch position. The altitude of the drone is always described based upon where it's launched from. And D is distance from pilot. So how far is that from me? So it's about 12 meters away from me. There's certain legal limits about how high you can fly, how far away you can be from the drone. So the drone could be 4 kilometers away, but legally, you got to be much closer to the drone while you're flying it. This gives us a map of where the drone has been on this flight. So there's not really any features. We're in a rural area. This is in Oxfordshire, and the white is a sort of a trail in plan view of where the drone has been. This piece at the bottom right is the first-person view. So there's an additional camera as well as this camera. They're glorious high-resolution 4K video. There's a little camera on the front that gives a feed. It's not recorded, but this sees what the drone sees essentially at all times. So while this screen I can move and operate, this one stays fixed and tells me what's right in front of the drone at all times. Now, while all this is happening, there's other you go into settings, there's other information like this stuff, for example, that's inside the same app. We flick in and out of that. We got some shortcuts on our controller. While we're doing all this, we are also required to observe the environment. And what happens if somebody arrives on site who we don't know, or is in a place where they shouldn't be? This happens. What happens when there's another drone on site? It's happened to me now 3 times where I've turned up to do works and there's 3 unannounced, unscheduled drone flights taking place. What happens if there's a bird of prey? In this precise location, there were 3, I think, kites flying around. I'm not a bird expert, but that's what was suggested from my colleague. What do you do about that? There's in each of these scenarios, there's a sort of a bit of a rule book, but you're also operating in real time and you have to take decisions in real time. And you're there with a limited amount of time. You're constantly racing against the clock. 1, because you've got limited battery capacity for each flight, and 2, you've been commissioned to do work, and there's a finite amount of time allocated to carry out these works. I'd love to spend weeks in some of these locations, but reality is I get maybe a day. Or in the case of the second slide I showed you, I was on site I was flying for less than 15 minutes. And yeah, you're capturing the data. So capturing the data as well as all these other things. The data capture can be autonomous, and so too can the flying. They can both be programmed in. A lot of the time it's not. A lot of the time we have to be manual flying. We have to manually capture the data. We do have 2 controllers. So we can give another controller to what we would call a payload operator. They can control the camera. We always have 2 people anyway on site, minimum. And a lot of the jobs I do, I actually prefer to be operating both myself. I find that the extra communication required with another person can potentially be worse and slower and invoke more steps than me being able to operate both the drone and the payload simultaneously myself. Incidents, jumping along, they do happen. Awful thing, having to pick up I think that image on the right, there's about 100 grand of equipment there. There's a LiDAR unit that was brought in from the United States, and serious issue. Nobody was hurt. Could have been absolute catastrophe based on what did happen, but fortunately it was okay. And it's really important that we have an internal system to make reporting easy and free from blame. We don't want a blame culture. We just want a learning culture. We want to understand what happened. What's important to stress here is I've not gone to any kind of school other than doing my 4-day course to get my permission for commercial operations from the CAA approved course. Anyone can do that, literally anybody. It's not hard. The training, the understanding the workflow, the methodologies, the software, the experience on site, like there's nowhere to go to learn that. Not yet. I think University of Bath are starting to offer a course where you get your CAA approved certificate and you learn a lot more about these things. And I was delighted to see that because I think it's a really good thing, a pathway for a career for a lot of people. And there's a big need for it, huge demand. But we don't have, there's no textbook for a lot of these things to go to. So it's really important you've got a system in place that promotes learning and promotes a blameless culture of sharing information. And we actually share the information with our competitors. Well, we're one of 4 companies on the framework. We meet up quarterly to have a safety briefing when we discuss incidents that took place and try to learn from each other. This incident in particular, we contacted the AAIB and requested that they carried out an independent investigation to understand what happened and to make sure that the information was distributed across the relevant industries. So I had to lead up that. The insurance company as well. They were probably more pedantic about the details than the AAIB, as you might expect. Yeah, the reporting culture. So if we can get people to report small things like a hairline fracture and take ownership of that, it'll promote an all-around culture of incident reporting. You can see here on this image, there's a micro SD card slot and a really small screw. So it's probably a little bit more than what you might call a hairline fracture, but it's in a critical part of the drone. This holds the landing gear of this particular drone. And the drone would definitely be able to fly with this, no problem at all. Highly unlikely it's going to have any effect on the performance of the drone or the quality of the data capture, but getting people to log this information and to share it at an early stage, it encourages then, or it rules out an apprehensiveness to report serious issues when somebody might feel they may be deemed responsible. We upload the data for further review after a flight. I'll show you that in a second. We assess UAV's performance, we check for errors, review suitability of flight plans, and prepare for our next operation. So we have this system that we use, Air Data, really good software. You can see you can track where your drone flew. We do this at the end of every mission. Where did the drone fly? We can download a KMZ of that, Google Earth. We can also replay the flight, and we can obtain notification information that happened during the flight. So you can see here at point F, there was a data loss, downlink connection loss for 1 second. So that's a cause of concern. And we would then go in and try to understand, well, what happened? How did that happen? Why was there a downlink? 1 second could be the difference between something serious or otherwise. And we can play this. We can play through the flight and replay the whole flight. And you can see here on the right, it shows you where the controls were used, the joysticks, what way they were positioned. And we can monitor the cells, the voltages, all this kind of stuff. Power, really important information. Battery cells, again, this is all stuff we do after a flight. We check through it and try to identify any problems, were there any issues, and then we obviously do maintenance as and when required. This is a data set from a bit of track. In railway, there will literally be somebody responsible for it. You can look at that and say there's nothing there, right? But there's somebody responsible for this. somebody responsible for this. These cables, somebody is responsible for. The track, the ballast, the sleepers, the third rail. This is electrified rail. So there's an electrical current running through here, and it will destroy you if you step on it. Same as this. So again, you don't want to be putting people out in this location if you don't need it. This is a low resolution file made to get captured from photographs, made for getting housed on this platform, so I can give you a demonstration. The original files, source files, are considerably larger. This is actually the same area. So it's slower, this, but it's a lower resolution. So what we often do is we're tasked with sometimes getting really high resolution, small areas of focus, or we capture large areas. I guess architecturally speaking, it's a bit like having a site plan and then having a site location plan and then having perhaps a detailed drawing at different scale. You could jump from scale 1 to 1000 down to 1 to 5. I guess it's a similar approach. It requires different resources and different types of flying to capture. That's it, I think. Any questions?
Thank you, Paul. I will stop the recording now and open the floor for questions, if that's okay.